In this presentation, you learn the 3 tests or criteria for similar triangles. Given these 2 triangles, when do we say they are similar? Let us recall similar polygons. If 2 or more shapes or polygons are similar, then they have the same shape, but not necessarily the same size. Their corresponding angles are equal. The corresponding sides are in the same ratio, and that same ratio is what we refer to as the scale factor. The symbols, the wave-like line or the 3 vertical lines are used to indicate similar polygons. For example, triangle ABC is similar to triangle FDE, which is the same as you use the 3 vertical lines. In this presentation, I will use the wave-like line to indicate similar figures. Let us also recall a relationship between sides and angles of a triangle. The longest or shortest side of a triangle is opposite the largest or smallest interior angle, or vice versa. Let us look at this example here. We have that right triangle, right? So we are supposed to establish the relationship between the sides. The one in red is opposite the 30-degree angle. Then the one in green is opposite the 60-degree angle. Then the last one, the 90-degree angle, is opposite the side in black, right? Which is a 90-degree. So this is all what we mean by opposite. Look at the angle, then the side that is opposite. That's how you can identify them. And this right triangle is a well-known triangle where we know the hypotenuse side is 2 and the other side is 1 and the other side is square root of 3, which is the same as 1,7. So that as it is, the 1,7 is opposite the 60-degree, the 1 is opposite the 30-degree, then the 2 opposite the 90, which is the biggest. So either way, if you are given a triangle with the known angles, you can actually arrange the sides in terms of from biggest to the smallest or from smallest to the biggest. Let us note that the ordering of the lettering in naming similar triangles is guided by the relation between sides and angles, right? Such that now, as an example, let us look in the diagram. We are already told that triangle ABC is similar to triangle FDE. Now, the task is, let us complete A. What is the angle equal to angle A? To do that, all what it means is I have in the diagram to identify what is my angle A. This is angle A. And that angle A is opposite the side BC, right? So I also wanted to identify the side that corresponds to BC in the other triangle. To do that, I go to the similarity statement. BC occupies the last position of the lettering. So it corresponds also DE, which occupies the last 2 positions of the lettering. So that means the DE is the side that corresponds to side BC. Therefore, it is opposite the angle F, meaning the angle F is equals to angle A. So we safely write angle F as the one which is equal to angle A. Let us go on to B, where now we wanted the ratio AB. Now the fact that now we want the ratio AB, or what it means is we go to our diagram using the statement from the similarity of those 2 triangles. AB is occupying the first two positions. Therefore, I'll also pick the two letters occupying the two positions, meaning at the end it should be over FD. That is all what it means. Right, I go to the next one. I have FE as the one that is at the bottom. But then I go to the FE, it is this one and this one. So in the first triangle, I also want the first and the last. Therefore, the one at the top should be AC. Right, BC is occupying the last two. Therefore, at the end of the day, I also consider the last two in the other triangle. That is the last two sides. Therefore, at the end, BC is corresponding to DE. That is what is important about the order of the lettering in naming similar triangles. As you look at them, be guided by the relationship between the sides and the angles. Now, as example number 2, in the diagram, the two triangles are similar. Complete the similarity statement. Triangle ABC is similar to what triangle? Now, what I simply have to do is I need to just try to identify the side AB, what side corresponds to AB. Then let me identify my AB by putting red so that I also do the same. So when I look at AB, what is peculiar is the angle in red marked the dot blue and the theta. I check them on the other side. They are on the side DF. So that means AB corresponds to DF or FD. But now to decide whether is it DF or FD, I'll look at the A is starting from the blue dot. Therefore, I have to use the FD as my starting point. Therefore, FD, then the E. So this is the similarity statement, and see how I am analyzing, always trying to check the angles and how things are situated. Now, we jump into the 3 tests or criteria for similar triangles. Here we have the angle tests. It simply states that if 2 triangles have 2 corresponding interior angles equal, then all angles are equal. That is, in words, we are simply saying if 2 angles of one triangle are congruent to 2 corresponding angles of another triangle, then the triangles are similar. We can model this by putting the diagram as it is, so that at the end of the day, you will see that the angle in A corresponds to angle in D, they are equal. Angle in B, they are equal to angle in E, right? So that is the model. Then we go on to the symbols. How do we write the statement written in words? In symbols, we are simply saying angle A is congruent to angle D and angle B is congruent to angle E. Then we can safely conclude that triangle ABC is similar to triangle DEF. Let us look at an example where now we are going to check whether the 2 given triangles are congruent using the angle test. Now, as we are told that HG is parallel to JK, we want to prove that triangle HGP is similar to triangle KJP. So let me just try to indicate one of the triangles so that at least you can easily single out the triangle. So This is one of the triangles. Then the one in black is the other one. Those are the two triangles we are trying to check whether are they similar, right? But you realize that here we don't need to go into trying to check which are the corresponding sides because that is already given for us. We are told that check whether this is similar to that. It's written for us. Now, we have to develop a plan reasoning backwards from the required to prove. That is, you ask yourself, how can I prove that triangle AGP is similar to triangle KJP? However, in this case, isn't it that we know we want to apply this test, the angle. So we don't have to think of any other. That is the test we want to apply. Therefore, we quickly go into the diagram and try to identify any two angles which are corresponding. And when we establish that they are equal, then we can conclude that the two given triangles are equal. So let us present the proof in the two-column setup. Then in this case, I was quick to notice, and you can still do the same, that angle G and angle J are equal. Why? Because they are the Z or Z pattern on parallel lines, then G is as the transversal line, right? Then I need another second angle. In my case, what I simply did was I was also quick to notice that the angle 2 and angle 1 are equal, vertically opposite angle, because that is the intersection of J, G, and HK. The angles formed vertically opposite, they are equal, right? But you could have also realized that you could have taken this angle, that is angle in H, right, will correspond to angle in K as your second angle. They are also the Z or Z angles. On the parallel, the transversal line there is HK, right? So now I have the two angles. All what I need is to conclude that the two given triangles are similar by AA similarity test, and I'm done. Right? Let us look at the second test, the side. All corresponding sides of two triangles are proportional. Let us look how it is written in words. If the three sets of corresponding sides of two triangles are in the same ratio, then triangles are similar. The model to that is we are having those two triangles as they are given, right? And we are saying for us, they have the same ratio if we go by the three pairs. In simple, we are simply saying AB over DE is equals to BC over EF is equals to AC over DF. Then the two triangles are similar. That is what the side test says. And remember, the same ratio would simply say if we can establish a scale factor, then obviously the two triangles are similar. Let us look at an example now where we see how we should apply the side test. Here are two triangles given. They are saying define if a pair of triangles is similar. Write the similarity statement and the test used. Right, those two triangles, are they similar? We need to establish that. And here we are not given anything. That is all what is given. But you should have a way of trying to identify corresponding sides, corresponding angles, and so on, right? So all what you are given is length of the sides of the triangles. Now, when you write the required to prove, that is this part, it's you who is supposed to come up with. So how do you come up with? When you first write your triangle ABC as your first choice, just to mention a triangle, then as you try to find the correspondence of the sides, you start by looking at AB, the first two that you have written. That is this AB, right? Which is this side. I'm going to indicate it by red again. That is AB. Which side does it correspond to, right? The answer is AB has measure 7. 7 in the triangle ABC is the second biggest. That means I can safely write that here in the first triangle, 5 is less than 7 is less than 10. That's how they are arranged. I can do the same in the other end to see again we are having, that is what is the smallest. 2 is less than 2.8 is less than 4, right? So I've arranged them. So the fact that AB is 7, then it should correspond to the second biggest. So that means it has to correspond to this, right? This 10 should correspond to this, right? Then the 5 corresponds to this one, right? So this is how you can identify, right? So by then writing FD as my first is because I had realized that FD is the second biggest side of that triangle as compared to the first triangle, just like that. So they correspond. So this is what then made me to write in this format, right? So as it were, now you have your thing, then what you ask now, you are saying from the similarity statement that you have written, then you are saying AB over FD is equals to BC over DE is equals to CA over FE. Are we getting the same ratio? That is what you are supposed to show, that yes or no, for you to then decide whether are they similar or not. Now in this table, realize that now we are simply checking on the what do you call the actual ratios of the corresponding side. The first pair gave us 5 over 2. The second, the same. The third, the same. All three of them gave us the same ratio. That means the scale factor is 5 over 2, right? So from there, I can safely conclude that these two triangles are similar by side size similarity test. Okay, enough of that. Then the third and last one is the side angle side test. Two sides are proportional with the same angle between them. In words, we are saying if an angle of one triangle is congruent to the corresponding angle of the other triangle, and the lengths of the sides, including these angles, are in proportion, then triangles are similar. Let us look at the model. This is the model now, wherein we are simply saying we have an angle which you are given, angle in B and angle in E. They are the same. So as such, the corresponding side that should be in a given proportion should be the side BC, right? Which I can safely put as EF. then the other side, AB, then the other side is DE. Because they contain the angles that we are saying they are the same. That is important. So in words, we are simply saying if AB over DE is equal to BC over EF, and the angle in B is congruent to angle in E, then the two triangles are similar. And what is important is the BC and EF, they give you the same ratio as the AB and DE, but those sides form the rays or the arms of the angles that we are saying they are equal. Okay, let us look at an example where we use the side angle side test. Determine if a pair of triangle is similar. Write the similarity statement and the tests used. The similarity statement, you would see that the moment you write down to say, I want to show that the two triangles are similar, when you write that similarity statement, you would have analyzed the diagram itself. And like I have already said, to say you can pick any triangle, naming the letters. Then to decide on the other letters of the other triangle, now it's dependent on the first pick. So we are saying we are only given the two sides of the triangles and two equal angles, full stop. But before we go any further, the fact that we wanted to check on this, we are saying the sides we are supposed to work with, this is one of them, right? And this is one of them. We need to find their corresponding ratios, right? Then, for now, I've simply drawn in the first triangle. As yet, I need to identify the corresponding sides to the one I've already labeled green and red, right? So how is it? I've already written AB, that is here, triangle ABC. So AB would be the one in red. And the measure there is what? Is 12. Again, you can arrange the sides of this triangle ABC, starting with the smallest to the biggest. So 8 is less than 12 is less than 16, right? We can do the same to that other triangle, starting with the smallest to the biggest, right? So we are saying with the smallest is 6, less than 9, less than 12, right? So once you have done this, then we know the corresponding sides based on this. So that is now very simple for us to relate this. That means the side marked 8 correspond to the side marked 6. The side marked 12 will correspond to the side marked 9. The side marked 16 will correspond to the side marked 12, right? So BC now, which I've put the color red, will correspond to the side with 9, which is this side, right? So at the end of the day, this is why then, as you can see, that is DF, and this is exactly what we have here to then say triangle ABC is similar to triangle DFE. That is what you are required to prove, but it's you who have to write it. That is similarity statement, so that you see the correspondence of the sides and so on. So at the end, the question to us now, we are simply saying AB over DF. Then the green one, I didn't finish the green one. The green one is 16 will correspond to 12. So this is it. And besides, you can see the sides, they are the ones that are the arms or the rays of the angle marked the F and B, right? So if we are given that these are equal, can we arrive at this conclusion? Right? That's the question we want to answer. Then from there, the fact that we are trying to apply the side angle side, we don't have to think outside that. We are simply trying to identify the sides, whether they in the same ratio, then the angle is it contained. So first and foremost, this is a given information, right? Then we find what is AB over DF, it is 3 over 4. Then BC over FE, it is 3 over 4. And we are getting the same ratio, right? Then from there, the given angle is included in the two sides. Then at the end, we conclude the two triangles are similar by side angle, side similarity test. Okay, key takeaways from this presentation. There are 3 tests for checking similar triangles, right? Now, these are the 3: AA, SAS, SSS. But note that it is important to know the meaning of what is it that you are saying AA and what is it that you are saying SAS and SS. AA means as long as you could identify a pair of equal angles, then we can conclude that the two triangles are similar. Then A and D are equal. That's the first pair. B and E are equal. That's the second pair. Hence, AA is satisfied. Then when it comes to the side angle side, we are saying here is the angle, which is angle B, which is equal to angle E. Then obviously we should establish the two sides that formulate those two angles. So we are saying the first one, let me put the lines there so that at least things will be just clear. So we are saying the AB is this side, right? And it will correspond to what? To DE. That ratio of those two corresponding sides should be equal to then the BC, which should correspond to the EF. And that ratio should be equal to the first ratio. That is all what it takes. Once you establish that, then you can conclude. Then come the side. Here we are simply trying to say AB over DE as a ratio. If it is equal to BC over EF as a ratio, if it is equal to AC over DF as a ratio, then we can conclude that the triangles are congruent. So in all fairness, just know that if you're given any two triangles and you want to check whether those triangles are similar or not, there are 3 tests for checking that. Let's look at fact about similar triangles. Right, in similar triangles, there is one important fact: to prove triangle similarity, prove only 2 pairs of corresponding angles to be equal. You don't have to prove all the 3, because if 2 pairs of corresponding angles are equal, then the third pair of corresponding angle is equal. That is to say, right, here is the situation. You are given that angle A is equal to angle D and angle B is equal to angle E, right? Then angle C is equal to angle F. Why? Because the sum of interior angles of a triangle is equals to 180. What does that mean? It means, if I'm going to give you examples there so that we can check properly. Suppose I indicate that this angle is 50 degrees. then I indicate that this angle is 60 degrees, right? If that is the case, it's the same measurements here because we are saying the corresponding angles are equal. Right, so now if I am to add the two angles, that is 50 degrees plus 60 degrees, what do I get? I get 110 degrees, right? The fact that we know that the sum of the interior angles of a triangle is equals to 180, then to get what is C, therefore, angle C is equals to 180 degrees minus 110 degrees, and this will give me 70 degrees. So my C is 70 degrees, isn't it? Right? So at the end, there's no way F can be different because the angles that I've added in the first triangle are the same angles that I'm going to add in the second triangle. So as such, this is also 70 degrees. So the essence why we are saying if only two corresponding angles are equal, we conclude that the third one or the third pair is also equal. It's because of that reason, because we know the inside angle of a triangle add up to 180. Okay, kudos to you for watching. Please like, comment, share, and subscribe.